Okay, this is a question on Malus's law taken from winter 2023 variant number 13. A vertically polarized electromagnetic wave of intensity I0 is incident normally on a polarizing filter. So we can assume that this is the first one, which is I0 before the first polarizing filter. The transmission axis of the filter is at an angle 30 degrees to the vertical. So this is quite tricky because if you observe carefully here, the angle is 30 degrees, yes, from the vertical line, but it is not from the usual clockwise direction, but it is 30 degrees to the anti-clockwise based on the configuration of the figure that is shown here. So which you should use theta not equals to 30, but instead it is minus 30 degrees if you want to use the Malus's law, because we assume the theta is measured clockwise rather than anti-clockwise. So it's either you use 270 degrees or minus 30 degrees. Now the transmitted wave from the first filter is then incident normally on a second polarizing filter, and the transmission axis of this filter is an angle of 90 degrees to the vertical. So we can see there's a difference there. We need to express the intensity of the wave after passing through the second filter in terms of I0 basically. So what is Malus's law? So Malus's law states that any incident or the intensity of our filtered wave I1 will be equals to the original one multiplied by cos squared of theta, where theta is measured from the vertical axis of the filter in the clockwise direction. So we've got to be consistent in this case. So here, let's just label I1 and I2, where I1 is the intensity of the polarized wave after the first filter, and I2 is the intensity of the polarized wave after the second filter. So we just have to carefully plug in all the values. So I1 is equivalent to I0 cos squared, don't forget the squared. Theta here will be minus 30 degrees. You can either use minus 30 degrees or 330 degrees. I'm very sorry. So 360 minus 30 degrees. So here, if you plug in here, cos squared 30 degrees would give you, if you plug in your calculator, you will get 0.75 I0. So this is the first, from the first polarizing filter. And then the second polarizing filter, I2, will be equivalent to I1 cos squared. Now this theta is a bit tricky because we know that it is arranged 90 degrees from the vertical axis, but we need to consider not from the vertical axis of the second filter, but instead you need to consider where the waves are actually at right now, because right now before the second filter it is tilted by minus 30 degrees. So to get from minus 30 to 60 degrees, to get from minus 30 degrees to 90 degrees, it will total up to be 120 degrees instead of 60. So it would be, if you take theta 2, here is theta 2 and this is theta 1, we want to find out what's the difference. So theta will be equal to theta 2 minus theta 1. In this case, theta 2 is already 90 degrees and theta 1 is minus 30. So here you get 120 degrees as the angle in which the second and the first wave that passes through the second polarizing filter. So here you'll get 90 minus 30 degrees. So here you'll get I1 cos squared 120 degrees. So here you'll get 0.25 I1. So now, to get the final answer, to express I2 in terms of I0, so you substitute I1 equals to 0.75 I0 into 0.25 I1, so you get 0.25 times 0.75 I0. Here you'll get roughly around 0.1, if I'm not mistaken, use a calculator here. 0.25 times 0.75, you'll get 0.1875 I naught. So here you can round it off to 0.19 I naught here. So you get your answer as C in this for this question.